Hello and welcome. This is Mr. Rafales, engineering instructor here at Mariemont High School. First of all, I'd like to say thank you for joining us, taking the time for this virtual open house. I know we're all busy, so thank you for taking the time to watch all these videos for all of your child's classes. Again, my name is Mr. Rafales. I teach the engineering courses here at the high school, and I teach some engineering courses at the junior high in the afternoon. Plan for this virtual open house, I'd like to just tell you a little bit about the classes I teach here at the high school. Tell you a little bit about myself, real quickly, maybe show you the classroom, and give you a little information about the Schoology page. One good thing about virtual open house is I can talk for as long as I want. Normal open houses, we only get about 5 minutes together, so it's good for me. I don't know if it's good for you, but I can talk for as long as I want. And you can know what your children suffer through when they're in my class and I get to rambling. First of all, everything on this PowerPoint is, not everything, but all these images are links, and the PowerPoint is below this video in the Schoology open house folder. So if you want more information on Great Oaks, Project Lead the Way, feel free to click on these links. Technically, I'm a Great Oaks employee. I'm what's known as a satellite instructor for Great Oaks, where instructors who actually go on to district campuses, such as Mariemont, to teach certain courses. I always say I'm in the best of both worlds. I get to work for Great Oaks, and I get to work in the Mariemont school system. Two amazing districts that I could not be luckier, in my opinion, to be working at Mariemont and with Great Oaks. It's really, I feel very privileged to be a part of the Mariemont family. The curriculum I get, sorry for all my ums and uhs, my screen is doing weird flashings right now. I'm not sure if you can see that or not. All of the courses I teach at the high school and at the junior high come from the Project Lead the Way curriculum. This is a national curriculum recognized by national universities all over the nation. If you click this little image here, it'll take you to the Project Lead the Way website, and you can look up different courses and get a lot of details on the actual curriculum that I teach. The courses I teach here at the high school are designed to be taken sequentially, with the first course being an Intro to Engineering course. Mostly this is designed for your freshman, sophomore level students. However, anybody can take this course. I encourage anybody and everybody to take this course. It's a lot of fun. The intro course focuses on the engineering design process, and it focuses on this through lots of hands-on projects where we get to use the engineering design process over and over and over again. So we do the brainstorming, we do the sketching. From the sketching, we build prototypes, and then reiterate designs and adapt them when we need to. So through this process, students will learn technical drawing, how to create technical sketches, through a few different types of sketches. They'll also learn how to take their designs and put it into CAD software, so we can have 3D models of their designs. And then they build prototypes, and we'll build prototypes out of all different types of material, from basic craft supplies, to 3D printing, to laser cutting. I like my students to be able to use and experience as much and as many different types of materials as they can. I have all kinds of tools, bandsaws, drills, all kinds of tools we can use. See, I'm already rambling. One project, I do want to show you a few projects. The most recent project students have done is they've built prototypes of, stand back here, sanitizer squirt bottles and towel holders. So every student kind of came up with their own ideas and then built a prototype of like a thing to hold a sanitizer squirt bottle and something to hold the towels that we use in class regularly. Whenever students come into class, they always spray their station down. So here's one prototype that a student did, which was pretty neat. Here's another design. It's kind of a shelf design with a bar holder, if I can get it in the video here. So students had to brainstorm ideas. From those brainstormings, they had to create a orthographic sketch, and then they built a prototype based on that, and then presented their ideas to the class. In the future, they'll do similar things, but also with CAD software. We'll do all kinds of fun things. Check out the PLTW website for other things we'll do in class. But a few things that I have planned, we might make a carnival beanbag toss game. We're going to make a motorized automata toy. We'll make a puzzle cube. And all of these things start off with brainstorming, sketching, putting it into the CAD software, and then actually building it. And it's a lot of fun. Students get into it. I see so many unique ideas. I need to stop talking about it because I can go on and on. The next course in the sequence is the Principles of Engineering course. Now we're getting to students who are thinking of really getting into engineering, maybe in college or as a career. This course does have more math in it, all algebra based, so no calculus. This course is designed for mostly the sophomore level or junior level. And the Principles course, we get into all the different types of engineering. So we'll do mechanical, electrical, we do material engineers, electrical engineers, if I didn't say that already, pretty much every type of engineering other than chemical. So they'll start off with mechanics, then we get into robotics and programming and circuitry. We'll move on to materials and structure. We'll do some hydraulics and pneumatics. And again, all of this is hands-on projects, reinforcing the design process, but getting more into the engineering and some of the math involved. Right now, students are building, this will be hard to get into the picture maybe, they're building these contraptions, which will have all different types of simple machines from wheel and axles to inclined planes, screws, pulley systems and levers. And then the students will use these to calculate the mechanical advantage you get from simple machines. And then they actually get the logger pros out so they can put an applied force on these and get the actual data to know the actual mechanical advantage they're getting from these machines. So a little bit of math, but it's applied, and they get to really apply what they're learning in their math classes. And it becomes not just math problems you're doing. Not that that's bad. I've taught math for years. But it's an application of a lot of the math they learned. And it's very hands-on. It's a lot of fun. Students really get into it. Later on in the course, they'll start building robotic type things, manufacturing factory type things. Like they'll have a few different things. One is the cookie topper project, where they have to build a assembly line type of conveyor belt machine that moves a cookie down to place candy on top of the cookie and set it off into like a little basket area. They'll do the electronic safe, where they have to create a safe that allows you to program your own 4-digit code to open the safe, but if you put the wrong code in, it locks the safe. They'll make, before Christmas, I'm hoping to have a laser tag robotic challenge where they'll build and program their own robots to play a laser tag competition with each other. And then later on, they will build bridges. They actually build the bridges. They'll calculate truss forces for each of the trusses in the bridges. And then we apply a force to the bridge to break the bridge, and we record it in slow motion so we can actually see the compression and tension forces that they've already calculated within each member of the bridge. That works sometimes. Sometimes it doesn't work, but it's fun. Students have a lot of fun breaking what they spent a lot of time building and calculating. And then we'll get into some hydraulics and pneumatic things too. Excuse me for being so fidgety. I'm still getting used to recording myself. So that's the principles class. And then we move on to the third course, which is digital electronics. And just so you know, in the Project Lead the Way curriculum, these first two courses are pretty much the required courses. But then after POE, it branches off and you can take lots of different engineering courses. The one we're offering right now at Mariemont is the digital electronics courses. But But there's an aerospace engineering course, there's a biomed course, there's environmental science course, an architectural course, computer science course. There's so many different branches. So I'm hoping within the next couple years to bring another engineering course to Mariemont. I think the aerospace engineering course would get a lot of positive feedback. I think students would really be into that. The digital electronics course focuses on circuitry and circuit design, a lot of soldering and proto boards. Right now students are using just your basic breadboard, and they're learning about LEDs, resistors and capacitors, series and parallel circuits, Ohm's law, and we're just getting started here. We're about to move into integrated circuits. You've all seen these little things on, in the movies on the hard drives and things. But it's the fundamentals of electronics. So right now students are not coding at all. They are learning how to take real world problems, turn it into binary systems of zeros and ones, and then how do you wire that with integrated circuits and different components to find a solution to the problem. They'll do things like they'll have to make a voting machine, they'll make a toll booth machine where a toll booth has to open and close depending on certain criteria. They have one thing that's kind of fun that they really get into is they'll have limit switches, which are just switches that you push in like this, and a series of those that act as a copy machine. And depending on if the switches are up or down means there's a jam in the copy machine, and certain things will have to happen based on that. That's called the copier jam activity, which is fun. And then students will get into microprocessors and the proto boards. These are much more advanced breadboards. They have all kinds of buttons, switches, LEDs, digital 7-segment displays they'll learn how to program. And again, they're doing all this without any actual coding. We're following the flow of electrons here using integrated circuits. It's a whole new way of thinking. It's almost like logic problems, but I don't tell the students that. And again, they have a lot of fun learning how to do that on these proto boards and combining integrated circuits to make something actually function and work. After that, they do get into coding. We use the Arduinos. These are a lot of fun if your child is really into programming. The Arduinos these things cost less than $20 on Amazon. The Arduinos have an actual text code, and they'll learn how to program these to make basically anything they want. And our kits come with like joysticks and infrared sensors and all kinds of things. So come second semester, they'll be learning how to program Arduinos to make their own projects and things. So I'm sorry, I'm at 13 minutes. Holy moly. This was supposed to be 8 minutes. Anyway, I'm done rambling about the courses. Click PLTW if you want to know more about them, or shoot me an email. I do want to talk about Schoology real quick. First of all, here's my email address. You can click it. It's a link. You're on the Schoology site right now, but you might be on your child's Schoology page. Every parent has an access code, so you can log in with a parent to see assignments, to see your student's calendar, to see your child's calendar, to see what assignments they're working on. So if you did not receive your access code from Mariemont, you should have gotten one for each of your child's classes. Here's a little link that tells you how to sign up, by the way. You can click this link. If you do not get the access codes, you can email me. I can just send you the access code for my course. So you can email individual teachers, but I think the office also has the access codes. So please send me an email. I think I only have 2 parent accounts set up right now for most of my classes. So sign up for the parent account. A little bit about myself, and then I will stop talking. I'm Mr. Rafales. I've been teaching either math, science, or engineering for the past 15 years. Engineering, I've only been teaching for 3 years. This is my 3rd year teaching engineering at Mariemont. The previous years have all been teaching just about every math or science class that's out there. I've taught at the high school level, math and science, and at the college level at UC and Cincinnati State. I have 2 bunnies, 2 dogs, 2 guinea pigs, and I have 3 kids. This is an old picture. Please do not tell my wife I put this picture in the PowerPoint. And it's old because my littlest one is now at Mariemont Elementary School in their preschool program. He is in high school, he is in 4th grade, and they are in the West Claremont School District, which they're not Mariemont, but I'm very pleased with what they're doing. And I have 2 dogs. This one gets in the garbage all the time. And here's a bunny that I was taking on a walk. Yes, my bunnies have leashes. I will stop now because this is even longer than I expected it to be. I apologize, but now you know what your poor children suffer through in my class, and they know they can get me off topic very easily. Thank you again for coming to this virtual open house. Please get in touch with me at any time. Shoot me an email. Give me a phone call. I love talking about the students. I love talking about the classes. I'm uncomfortable talking about myself. But I love talking to you guys about what your kids are doing because they're doing really cool stuff. And they never cease to amaze me. So again, thank you. Have a great night. Rafales signing off.